today's lesson, we're going to look at molar concentrations. This is going to be one of the final parts of your calculations, apart from the energetics. So to recap, before you do this lesson, you should have done moles equals mass over mR, which was the first lessons, and you should have done gas volumes, where moles equals V over 24. So make sure you tune into those lessons first. Now, concentration. What is concentration? Well, concentration is how much of something is present in a particular volume of space. Now, we obviously need standard ways of measuring this. So in chemistry, we say, how many moles are there in 1 decimeter cubed of solution? So 1 decimeter cubed corresponds to 1 liter or 1,000 centimeters cubed. The conversion obviously is that you divide centimeters cubed by 1,000 in order to get decimeter cubed. That was in previous lessons. Now, the formula for concentration is as follows. Concentrations is moles divided by volume, because obviously you have moles per decimeter cubed, so moles per volume, how much of something there is in the volume of space. The version I prefer is the following: moles equals C times V. Like a CV that you used to do to apply for a job, you used to give people your CV. So C times V, concentration times volume is equivalent to moles. The disclaimer is that volume must be in decimeters cubed. So probably 90% of the time, they're going to give you centimeters cubed. So you will need to divide the volume by 1,000 before you put it into here. So some people like to say moles equals CV over 1,000, if this is in centimeters cubed. Now, this is the triangle for those of you that prefer it. So moles is NCV. We're now going to practice just applying this concept to these building blocks, as I like to call them, to calculate concentrations and moles using the new formula. I'm going to do one example from each exercise and then leave it to you. So in the first one, calculate the concentration. Well, concentration is N over V. So in order to solve this one, you need to do the moles divided by the volume, because remember that the units are going to be moles per decimeter cubed. So in the first one, we're going to do 0.1 divided by, now this is the catch, the 200 centimeters cubed has to be divided by 1,000 first, which gives you 0.2. So that will give you 0.02 moles per decimeter cubed. Now you can write mole dm minus 3, or you can write mole slash dm positive 3. It's up to you. The second example asks for moles. So moles equals CV. So C is 0.2. These are the units for concentration. And this is volume. However, I have to divide it by 1,000 first to make it decimeter cubed. So 100 over 1,000 is 0.1, which gives us a final answer of 0.02 moles. For moles, you're not required to put any units. Okay, exercise 3. Let me just check. Yeah, that's fine. So exercise 3. I'm going to do the first one. Now here, there's actually one slightly extra concept as such. Concentration, obviously the standard way of measuring it is the moles per decimeter cubed, but you can also do it in terms of mass per decimeter cubed. So how many grams of solid did you add to 1 liter? So that will be G slash decimeter cubed. Now to interconvert between the two, you do as follows. Because moles is here, and this is mass, grams is a form of mass. If you remember the formula moles equals mass over mR, then mass equals moles times mR. So moles times mR. So look, you already have moles. The per decimeter cube doesn't change on both sides, so you don't need to worry about it. So essentially, if you do moles times mR, you'll get mass, which is what you want here. That's why if you take the moles per decimeter cubed and you times them by the mR, you'll get grams per decimeter cubed. And you can go vice versa. If you want to go from grams to moles this way, you would divide by MR, and this way you would times by MR. Okay, so if you go from left to right, you're going from mass to moles. Well, to get moles, you do mass over MR. That's why you would divide by MR. So in question 3, they're asking you to make it into grams per decimeter cubed. So you're actually going to go backwards, so times MR. So in the first one, you're just going to do 0.1 times the MR of NaOH, which is 23 plus 16 plus 1, 40. That'll give you an answer of 4, but it will be grams per decimeter cubed. Okay, or grams / decimeter cubed. I prefer to put the minus. I will do for you one more example, 4. 0.2 moles is dissolved in 250, calculate the concentration. Well, the units of concentration already give me the formula. It's moles over decimeter cubed. So it's moles over V. C equals moles over V, just like here. So moles is 0.2 divided by, now remember, this has to be in decimeter cubed. So that's 0.25 when you divide it by 1,000. So that will give you a final answer of 0.8 moles / decimeter cubed, if you like. Now, to make it into grams per decimeter cubed, you just times the 0.8 by the MR, which we already worked out was 40. So that will give you an answer of 32 grams per decimeter cubed. That completes the first section, which is just the simple one-step techniques of measuring and applying the formula. Next, I'm going to go over kind of the 3-mark questions, just like we did with reacting masses, we did with volumes. We're going to do it with concentration. I would have a go at finishing this sheet first and checking your answers there. So if I go to the next sheet, titration calculations, I'm going to demo 2 questions. One from here, and I'll do one from a past paper. So the steps are actually given to you here. I like to call them Mr. C. Okay, if you're looking for concentration. If you're looking for volume, it's technically Mr. V. However, don't confuse that with gas volumes because it's a different formula. So what I'll do is I'll do for you these 2 questions and then one from a past paper, just so you can see both. Let's start with Mr. C, the classic Mr. C, calculating concentrations. So it's very important you read what the question has given you. So they've talked about sodium hydroxide, which is this one on the left, and they've given you this. Now this is centimeters cubed, so it's volume. This is mole per decimeter cubed, so it's concentration. This one is the acid and its volume. And we're looking for the concentration of the acid, this one here. So step 1, moles. Moles equals CV. This is the new formula we learned in the previous part. So C 0.2. Now V is 25 over 1,000 because it has to be in decimeter cubed. That will then give you moles. So if I put that into my calculator, 1 second. 25 divided by 1,000 times 0.2, we get 0.005, or 5 times 10 to the minus 3. The second step, like it's been in the previous examples, is ratio. The ratio is 2 to 1. Can you see there's 2 of this and 1 of this? Therefore, because we just found out this one, we need to halve it. So we divide that by 2, and we get 0.0025. Finally, we need to find concentration. So concentration formula, as above, is N over V. Now the N is the thing that you just worked out. Now the V is the V of the thing that we're looking for. So don't make the mistake to plug in this V. You got to plug in the V of the acid because we're looking for the concentration of the acid. So 28.7 over 1,000. So 28.7 over 1,000 would actually give us 0.00287, I believe. We'll just check. 1, 2. No, I put too many zeros. Apologies. 0.0287. 1, 2, 3. Yeah. So if you do this division, you will then get the right answer. And the answer should be 0.0871 moles per decimeter cubed. Because we did the moles over the volume. The volume had to be in decimeter cubed. That was the catch. So to recap, you find your moles with a new formula. You do your ratio like in all the previous questions, which should now be easy to you. And then whatever the question is asking, if it's asking for concentration, you do C, moles over V. If it's asking for volume, then you would have to rearrange this formula for volume, which will actually be V equals moles over C. I will show you that with number 1 as the example. So 0.1 sulfuric acid volume, that's what we're looking for. I'm going to put a box around it. Reacts with 30, that's volume. This one is concentration, and it's sodium hydroxide once again. So we start with the sodium hydroxide, N equals C times V. C is 0.15. V is 30 over 1,000. So that's step 1. I'll pop that into my calculator. I get 0.0045. Or your calculator might say 4.5 times 10 to the minus 3. Perfectly fine to write that. Just don't do any rounding. Ratio is 2 to 1 again, because it's 2 going to 1. So because we know this one, we need to half it. So 0.0045 divided by 2. And that will give us 0.00225. In the final step, instead of C, we're looking for V. So as I said, V, you swap these two, is moles over C. So V equals moles over C, which equals 0.00225 over, and the C is given to us already in its normal units, which is 0.1, which is then giving us a final answer of 0.0225. But what units? Well, the standard unit of volume is decimeter cubed. That's why it seems so small. So often in an exam, they might ask it to be converted to centimeters cubed. So you times it by 1,000, and you'll get 22.5 centimeters cubed. And this is how you solve these questions. I'll just screenshot this and save as a PDF. A little messy, but this is the method. Of moles, ratio, concentration, or moles, ratio, volume. Just make sure you plug in the right one for the right one. The common mistake is to say put 30 with 0.1. That's wrong. You got to read it, underline it, and make sure that you use the correct concentration and volume for the correct substance or compound. Now, I'm simply going to take up a past paper, and I'm going to go through a question from a past paper to finish. And that will be the end of the concentrations calculations. So it doesn't actually matter which exam board we pick. Okay. I'm going to pick an AQA one. This is exactly the same in both syllabi, Edexcel and AQA, so it just really doesn't matter which one you pick. Let me just find the correct question. Okay, I found one. This is the 2022 paper. All right, so let's get on with this, 8.3. I'm just getting my calculator ready so it can be smooth. Okay, now remember that the actual titrations topic will be a separate unit that I'm going to teach, where I'm going to go over the equipment, how to find these volumes, how to find mean titers, concordant results, all these things. Now we're looking just at the calculations. So I already know if it says concentration that we're looking for, and I see these units, I know I'm going to be using N equals CV somewhere, and I know I'm going to do Mr. C, moles ratio concentration. Those will be my steps. So 25 acid, that's this one here. And find the concentration of the acid. So we're looking for this one. We have all the information on this one, which is the barium hydroxide here. We've got the volume and we've got the concentration. For the acid, we just know the volume. Step one is moles. Moles can only be worked out for this one, not this one. You can't do this one directly because you only know one piece of information. Don't get confused and start doing mass over MR because this is not mass. So concentration is 0.1 times 23.5 over 1,000 because it has to be decimeters cubed. So when you do this, you will get 0.00235 moles. Don't do any rounding. Then the ratio, it's 2 to 1, 2 to 1. But interestingly, we did not work this one out, we worked out this one. So we're going from here to here. So if this one is 0.00235, it needs to be doubled to get to this one. So we're going to do 0.0235 times 2, and we get 0.0047. That will be the moles of HCl. Now we're looking for concentration of HCl. So if we rearrange the formula, C, you divide both sides by V, and C is moles over V. The moles are going to be 0.047 over, now V. V must be for the acid, which is this one. But V needs to be in decimeter cubed, so 0.025. When you do this division, you will get 0.188 mole per decimeter cubed. And that's what they asked for, the moles over the volume. So that completes the lesson on concentration. And that is the final part of the first unit of calculations. There's only one other part of calculations, which is to do with bond energies. And then if you do it at Excel, it will be also calorimetry. So please practice these. It takes a while to get good at it. I will attach plenty of worksheets for practice. I have titration calculations 1 and 2 for you to practice. And see you next time.